Hi guys, welcome back from the ad break. So I hope you guys are a bit refreshed. Now we're going to look at some specifications, right, in terms of simplifying the expressions themselves. That include some exponents there. And then we'll also look at, firstly, when we are multiplying and dividing, what are the few principles that we need to follow. And then later we'll also look at when we are then adding and subtracting as well. What do need to follow from there. But for now, let's look at the concept of multiplication and division of exponential expressions. So remember that an exponential expression may include multiplication and division of terms. So it can be one term multiplied by another term over another term, right? That's what that means. Also, it may include some addition and subtraction of terms. And I know this one is the one that kind of gives you guys a problem at times because you just like cancelling out things. But we will look at it when we get to it. And then with the multiplication and division of exponential expressions, right? When an exponential expression only involves multiplication and division, the very first step that we need to follow there will be to rewrite all the bases to be in terms of prime numbers. Remember when I started, I said we're going to look at prime bases. This is where that comes in. Let's look at an example of what this means. So if I have 6 to the exponent of n minus 1 multiplied by 18 to the exponent of n, you're going to rewrite these terms as prime numbers, right? But only if it's possible to do that. Just from the get-go, change it to exponential form. But if you cannot, then you can write it as a product of two prime numbers that make that particular number, right? So this is where then the things we learned earlier on when we started doing our mathematics, your ladder method and your tree diagram method of finding prime numbers, this is where it comes in. So we know that 6 is the same as 3 multiplied by 2, and we know that 18 is the same as 9 multiplied by 2, but because 9 is not a prime number, I can convert it to be 3 squared. And all of this will be raised to n. And then from there, remember one of the laws that we looked at under brackets, we distribute that exponent using multiplication there. Therefore, it's going to be 3 to the exponent of n minus 1 times 2 to the exponent of n minus 1 times 3 to the exponent of 2n. Why 2n? Because it's going to be 2 multiplied by that n there. And then lastly, it will be 2 to the exponent of n. Now, remember guys, multiplication in mathematics, right, is a few things that we use. We use the actual multiplication sign, we use a dot, and we use a bracket. So please make sure that you understand this. You don't want yourself to hear yourself now saying it's 3 to the exponent of n minus 1 comma something, because really that wouldn't make sense. The dot means multiplication in mathematics. Unless we are in a language class, then it will mean a full stop. But here it means multiplication. And then also, when the second step of simplifying this will be to apply the laws and the definitions of exponents, right? I've actually applied one here where it includes the concept of brackets and raising one exponent to the other. Now, with this one, what this means is we left it at this point with the previous example. From here, you can see this is the same base as that base there, and this is the same base as that base there. What does that tell us? Then we can apply either the product rule or the quotient rule, depending on what is the operation between the terms. And the operation here will be a dot, which means multiplication. Therefore, remember the law. If I have a to the exponent of m multiplied by a to the exponent of n, the law is to say I must add my exponents, right? Therefore, I will then group them according to the same basis so that I can then add my exponents accordingly. So the 3 will go with the 3 there. which will make it n minus 1 plus 2n. Then multiplied by the 2 here, will go with that 2 there, and then it will be n minus 1 plus n. Then you know that n plus 2n will give me 3n, and then minus 1 does not have a like term, so I will leave it as is. And then n plus n will give me the 2n there. Then minus 1 remains as is because it doesn't have a like term, right? So the two main steps here is, 1, convert the terms, your bases rather, to be prime numbers. 2, apply the laws of exponents. From there, let's just look at, in practicality now, what exactly does this mean? The statement you're going to get for such questions will be, simplify the following questions. And they will at times add to say, leave your answers as positive exponents, right? But that's one of the requirements at all times. When you're having a division and all, they always tell you that leave your answers in positive exponents, because mathematically, we hardly leave our answers as negative exponents. Right, so the first question will therefore be 4 to the exponent of x multiplied by 2 to the exponent of x minus 2, all divided by 8 to the exponent of x minus 1. Now, I know you guys, and I know how you think, right? The very first thing that you will then think when you are in a situation like this will be to multiply the 4 and the 2 to get an 8. But you cannot do that. Why? Because we're dealing with exponents. The exponents normally take dominance over what we are doing. So where do we go? We go to the concept of prime basis. That's the main thing that we need to then look at here. So you know 4 can be written as 2 squared, which will therefore give me 2 squared, I will open brackets there, x multiplied by 2 to the exponent of x minus 2, divided by 8 can also be written as 2 cubed to the exponent of x minus 1. And then you apply your laws of exponents here. This will give me 2 to the exponent of 2x multiplied by 2 to the exponent of x minus 2, all divided by 2 to the exponent of 3x minus 3. Then, because we have both multiplication and division, we'll start with multiplication and then apply the division after, so that I don't confuse you guys. So, at the top, I'll start with multiplication. That will be 2 to the exponent of 2x plus x minus 2 over, I'll rewrite my denominator as is, which is 3x minus 3. And this will give me 2 to the exponent of 3x minus 2. And then I apply the quotient rule here, right? Which will therefore minus. I put this in brackets because I am subtracting more than one term. And therefore the final answer will therefore be, the 3x and the 3x will cancel out because it's going to give me 0. Then minus 2 plus 3 will therefore give me 1, which is the same as just 2. Remember, we don't necessarily write 1. Now, the second example will therefore be 3 to the exponent of x plus 3 times 18 to the exponent of x divided by 6 to the exponent of x plus 1 times 9 to the exponent of x plus 1. Same thing applies. You don't then start multiplying your bases or anything like that. Instead, you go to your prime basis. So this will be 3 to the exponent of x plus 3 multiplied by, so this I'm just going to write it as 3 to the exponent of 2x multiplied by 2 to the exponent of x, right? Where does that come from? It comes from me having 3 squared multiplied by 2 all raised to the exponent of x, right? Because it's 9 times 2, which is the 18. Divided by, here it will be 3 to the exponent of x plus 1 times 2 to the exponent of x plus 1 times 3 to the exponent of 2x plus 2, right? Because I'm going to distribute my 2 there. 9 is the same as 3 squared. Then from here, I will apply the laws all at the same time now, because with the previous one I showed you how you can do it so that you understand it. So this will be 3 to the exponent of x plus 3, then plus the 2x, right? That's what is at the top. What is at the bottom, I must subtract it, which is minus the x plus 1, and then minus again the 2x plus 2, right? And then multiply this by 2. I only have 2 of them, so it will be 2 to the exponent of x minus x plus 1, right? And then you can then work out your exponents there. This will be 3, this x, the 2x, and that x there will give me just 2x, so I will have 2x there. This 3 and that minus 1 will give me plus 2 multiplied by, then the 2 will be to the exponent of 1, which I am really not going to write. And this will be my final answer there. Please remember, you don't need to then multiply the 3 and the 2 to get a 6. But this will therefore be the final answer for this particular question. So as you can see with this question that we just did now, right, the main thing that you need to follow there, one is to make sure that your bases are the same, right? When I say bases are the same, some numbers you cannot really convert them straight away to a certain exponential form, but you will need to write them as a product of two numbers, right? As you saw with the previous example, just to show you what I'm talking about, right? The 4 can be converted, the 8 can be converted, but with this one that we just did now, I cannot convert 18 to anything that is in exponential form unless it's a product of two terms. Similarly with the 6, similarly with the 9, I can definitely do that because it then becomes 3 squared, right? So that's the main thing. So with everything that we've done, make sure, number one, that you have your prime basis, which I will just say it's PB, and after doing that, then apply the concept of your laws of exponents, right? Either the laws and also the definitions. Why am I saying the definitions? Because at times you will find that the answer that I'm left with here as the exponent of maybe this 2 is 0, right? I will not leave this as 2 to the exponent of 0. The next equal sign will therefore be to substitute this 2 to the exponent of 0 as 1, because that's what the definition says. But for this one, that's not what it says. So I'm just going to erase it so that it does not confuse you. But that's really the main thing that you need to make sure that you understand. Prime basis, apply your laws, your definitions, and then from there, make sure if you do not understand how to do this, just start with the top and work out everything that's at the top. Go to the bottom, work out everything that's at the bottom, and then combine them after that. And then you will get your answer from there.